The next concept that we're going to be talking about is relating pressure, the force that's exerted over an area, and volume, which we've already talked about. Now, if you think about it, if you look at this example, if I've got a gas that is within this container, okay, and its volume is 4 and its pressure is 1 atmosphere, if I have that volume, so I take it from 4 and make it become 2, my pressure is going to increase, and that makes sense. Because if you think about it, you still have the same number of molecules, but because you've decreased the volume, they're going to be bouncing off the walls of that container more forcefully because they've got less space to travel. So pressure and volume are inversely related. When one goes up, the other goes down, and that is Boyle's law. All right? How does this apply to our everyday lives? Well, when you breathe, what happens is before you actually bring breath into your lungs, your diaphragm is going to drop. When your diaphragm drops, that causes the pressure in your lungs to decrease. And it decreases because the volume in your lungs increases. So when your diaphragm drops, the volume increases, the pressure decreases, and because there's more pressure outside of your mouth than inside your lungs now all of a sudden, air is going to be sucked into your mouth, down into your lungs. When you exhale, your diaphragm moves up, which causes the volume to decrease, which causes the pressure to increase, which then forces the air back out. So when you're breathing in, you're not actually physically breathing in the air. The reason why air comes into your mouth is because when you breathe in, drop your diaphragm, which causes the air to immediately and naturally come into your lungs because the pressure in your lungs has decreased. So, in order to relate pressure and volume, this is Boyle's law. P1 V1 equals P2 V2. P1 refers to the initial pressure, V1 is the initial volume, P2 is the new pressure, and then V2 is the new volume. So let's look at an example of how to use this. So if I have a volume that has 30 liters of helium gas at a pressure of 103 kilopascals, I'm wanting to know what the volume is if it rises to an altitude where the pressure is 25.0. So my 30 liters is going to be my V1. My 103 kilopascals is going to be my P1. And then 25.0 is going to be my P2, and I'm solving for V2. Okay? So my P1 again is 103. My V1 is 30, and that equals my P2, which is 25.0, times V2. So when you solve this, I get V2 equals 124 liters. Let's make sure this makes sense. What I'm doing in this problem is I'm taking my pressure and I'm decreasing it, which should, because pressure and volume are inversely related, that should cause my volume to increase, and it does. So that's it. What we talked about is the concept of pressure, what it is, how we experience atmospheric pressure, the units of pressure, and then finally, Boyle's law, which relates pressure and volume. Okay, so here's the formula for Charles' law. It's V1 over T1 equals V2 over T2. So if you notice, if your volume increases, what that means is that your temperature is going to also increase so that that proportion doesn't change value. So while for Boyle's law, it was P1 V1, and when pressure increased, volume had to decrease, so they were inversely related. Charles' law shows us that volume and temperature are directly related. So when one goes up, the other goes up. When one goes down, the other goes down. Okay, and so you can see that in this diagram right here. When I'm at 200 Kelvin, if I increase the temperature, notice that the volume of that cylinder, it's a piston, right? Those gas molecules start moving more quickly, and as a result, the volume expands. So that further demonstrates that volume and temperature are directly related. Okay, the units for temperature, so remember for Boyle's law, your units for pressure and your units for volume could be whatever you wanted them to be as long as they matched up on both sides. Whenever we're dealing with temperature for our gas laws, however, temperature must be in Kelvin. Okay? So let's look at an example. So here it tells you a balloon is inflated in a room at 24 degrees Celsius and has a volume of 4 liters. The balloon is then heated to a temperature of 58 degrees Celsius. What is the new volume? So I'm going to be using my Charles law, V1 over T1 equals V2 over T2. Keep in mind, your temperature must be in Kelvin. So to convert from Celsius to Kelvin, I need to take my Celsius temperature and I need to add 273 to that. Okay, so I'm going to put 4.00 liters on top, 24, which is my T1, plus 273 gives me 297. That equals my V2, which is, I don't know, so I'm going to put V2 right there, over T2. Well, I need to take 58 degrees, and I need to add 273 to that, so you would get 331. Okay? Now I need to cross multiply. So what I'm going to do is I'm going to take my 297, multiply that by V2, and then I'm going to set that equal to 4.00 times 331. Okay, so I've got that there. Now to isolate V2 to get it all by itself, I need to divide both sides by 297. And so the answer that I get for my V2, once I divide by 297, and I round to the correct number of significant figures, which in this case would be 3, because 4.00 has 3 sig figs, 297 has 3, and 331 has 3 significant figures, I get 4.46 liters. The important thing for you to remember, even though the Celsius temperature has 2 significant figures, the important thing for you to remember is since I'm adding 273, I'm going to base my significant figures off of the Kelvin temperature, not the Celsius temperature. Okay?